Hello everyone, and welcome back to DMG. Often we don't realize how cool the mechanisms in our boring everyday electronics are. And I've become fascinated with looking at and exposing and finding out how these mechanisms work. And today, the seemingly mundane device with a fascinating mechanism inside that I'm looking at is the General Electric Everset. It's a 1970s alarm clock, early 1970s, that is mechanically programmable to automatically switch on and off on certain days. It's very simple in premise, but the way it works is pretty different than I expected, and it's also really cool. Because while something like this is extremely easy to do digitally, doing it mechanically is a whole other beast. So that's what we're looking at today. Let's get right into it. So as mentioned, this is the General Electric Everset. And while General Electric made a whole lot of clocks, this mechanism was only ever put on this one model. The Everset mechanism never made it onto any other except for this one model. It had two SKUs, and the one I have is the beige with the transparent plastic backlit dial. It's backlit by a neon tube, as all of General Electric's lighted dial clocks are. So flipping it over to the back, the whole clock is molded from this very sturdy plastic, and you'll see later that to take it apart, you scoop the mechanism and the electronics out of the front, so it comes out in a pretty unorthodox way. But on the back here, it looks pretty standard. Time and alarm set, and then alarm on and off. And on the bottom here, it tells you how to set your alarm. So you push in the days that you want it to turn on, and you pull out the days that you want it off. And this wheel automatically rotates. You set it to the day, AM or PM that it currently is. And then at about 1 AM or PM, this advances 12 hours. So it's not constantly ticking forward, it jumps. And you'll see the mechanism to do that in a couple minutes. But let's get this back off, or rather I should say, let's get the front off so that I can really show you what's inside this thing, because it's pretty damn neat. And there you go, there's your mechanism. Now, really unfortunately, this is a problem with GE's lighted dial clocks in general. The face is made out of a very thin, transparent plastic, or translucent, I should say. You can't see all the way through it, but it lets through the wavelength of light that the neon bulb emits. The neon bulb is tucked down under there beneath this reflective foil. It illuminates this piece of plastic that then shines through the face. But because these are exposed to heat and light because of what they do, and also they're exposed to UV, which breaks down plastic over time because they're just facing the world on a clock face, they shatter very easily. So unfortunately, that has happened to mine. Kind of difficult to avoid happening though. Well, there's our Everset wheel, and there's the rest of the clock, and they're bolted together in two pretty distinctly different sections. So on the right side, you have what's pretty much just a normal Telechron clock mechanism with the addition of the neon bulb down there. And then on the left, you have the Everset. Now, the only thing really linking them is this big metal bar. And remember how I said that the Everset wheel jumps from day to day? It doesn't continuously tick. Well, this brass bar is what shoves it over to the next day, like pushes the wheel forward 12 hours, at about 1 o'clock every day. Now, I can't plug in this mechanism and show it to you on camera safely because, like many things from the 40s through the 70s, this is what is called a hot chassis, meaning this is the chassis, this big metal plate here, meaning it's connected directly to one side of the AC supply line. So typically things nowadays, the chassis is grounded, but especially on a lot of vacuum tube equipment and some electromechanical equipment like telecrons, it just, fuck it, we ball. Plug the metal straight into the AC supply line. So that explains the very thick plastic case to completely seal off this mechanism. Now the part that I knocked off accidentally switches the alarm on and off. I do believe that spring goes there. Yes. So, see this lever here? This yellowed plastic lever? And also note this switch here. So see what happens. Note that mechanism movement. So the way that the Everset mechanism triggers the alarm is when this pin is pushed in, when the wheel rotates every 12 hours, it will flip this lever. And this, as a result, makes contact with the AC supply line that's connected to this side of the telecron mechanism. So it connects one half of the alarm circuitry to the other. So that is how the mechanical part of it works. And of course you have to switch off the alarm, which is this position there. So you would have to switch it off every day or else it will go off every 12 hours. But yes, when the wheel rotates to a position where the pin is pushed in, that triggers this switch to connect the alarm. So it works in a pretty simple way, but watching the mechanism move is really fascinating. And it's also fascinating and a little baffling that GE never used this design again, because it's a really good design and it's not that complex. It's not that like mechanically crazy. It's not like this significantly increases production costs or anything. All it's doing is there's just an extra lever and a little wheel that just triggers a mechanism that most alarm clocks already have. But let's look at a couple time lapses. So first one from the outside, you can see like 12:30-ish, the wheel begins to slowly rotate, and then it snaps into place when this lever has fully pushed it to the next position. And now here's what that looks like from the inside. Now the lever is actually braced against the case. There is this bit down here, the spring-loaded mechanism that is braced against the plastic case. So if the case is off, it doesn't always rotate properly. But that's what it looks like when a pushed-in pin rotates to the next day and then pushes the lever to trigger the alarm. So it's not an instant process. It takes a good 30 minutes for the mechanism to kick in. And that's pretty cool. There's not a whole lot else I can say about this. It's just a really neat way to expand on the already very reliable and versatile telecron mechanism. This is a super late telecron rotor, by the way. This is the latest series I've ever seen. It's very small, very slim, and it's pretty quiet too. This whole clock, even though it's analog, electromechanical, It only pulls 3 watts from the wall, because these Telecron motors being direct drive are extremely efficient. There's no rectification, there's no conversion from AC to DC. They just run straight off the AC power. The only conversion that happens is the stepping down from 120 volts to usually 24, and then the motor gearbox steps it down from 3,600 RPM down to 1. There we go. Back is snapped on, just needs to be screwed now, and relatable. These dials are so pretty. It's such a shame that they just explode so easily. There we go. Even though the faceplate is not in great shape, it's back together. But yes, has the same nice smooth movement as any Telecron, but of course with the awesome extra edition. So again, I can't say a whole lot much more about this. I just wanted to share the really awesome mechanism because I haven't ever seen anything else like it, or a device that contains, whether from GE or another brand. And I think it's really cool that they used just a regular Telecron. It's just the same motor, but it has extra levers and stuff added onto it. And the Telecron mechanisms are surprisingly easy to modify. The same motor, like the same basic motor, companies did a lot of different things with it, like snooze alarms. You know, you press it, it silences the alarm for 5 minutes, all mechanically. Sleep timers, keeps the radio playing for like 30 minutes until the clock runs it down, that sort of thing. So the Telecron is incredibly versatile, and this is yet another example of the crazy things that could be done with the exact same mechanism, but just adding a couple extra springs and levers. But yeah, that's it for this one. As always, thank you so much for watching. I hope these mundane things with cool mechanisms fascinate you as much as they do me. But that's all. Thank you so much, and I hope you'll come back and watch another one.